So together here, we're going to solve the unit problem, the first half of the unit problem, how long is a shadow? So on your notebook paper, we've labeled it 297 and page 302. So on page 297, let's rehash here. What's our shadow model? So go ahead and draw this about 2 or 3 inches, taking up a little quarter of your page here. So you have maybe just a stick figure here that you're drawing. You have your lamppost, and these are the variables in the shadow model that we were looking at. Here in the past couple of weeks, I've had some students say, are we still in the shadows unit? Are we still trying to find the length of the shadow? Where are we in this unit? So those students have been asking those questions. I've reminded them that all of the triangles we've been looking at, we have been trying to figure out if we could apply some of those geometric concepts to this model of the shadow, because remember when we collected the data, we found that the height of the object, the height of the light, and the distance from the light, they all played a part in this shadow, in the length of the shadow. So all 3 variables, but they all affected the shadow differently. Some of them, when you changed, the shadow got smaller. Some of them changed consistently. Some of them, one of them changed at like an exponential decrease. And so algebraically, we couldn't put these 3 equations together and solve the problem like we did with the pit and the pendulum. So we said, okay, so how could we do this geometrically? How could we look at this diagram? And now we can see, especially after looking at the information we started today with overlapping triangles and indirect measurement, we can see here that we have triangles happening here. So the person or the object is forming a triangle with the shadow, and the top of that object could extend then to the top of that light source and straight down. And now we have 2 triangles, and now the question is, are they similar? And we only need the minimum criteria for similarity is 2 angles. So the object, we could say, would be perpendicular to the ground. So it's going to form a 90-degree angle with the ground. The light source, remember we focused on that being perpendicular 90 degrees to the ground, and that light's not changing, so this is that lamp. That height's going to stay the same. So we have our little triangle, has a 90-degree angle, and we have the large triangle that has a 90-degree angle. Let's see if I can draw this a little bit better here. At least it's kind of horizontal. Do we have any other angles that are the same? This one right here. So here, fantastic. So this angle down here in the corner would be the same exact angle, because if I picked up the little triangle, I could place it there in the big triangle so that they are the exact same angle in both of these. So yes, we do have angle-angle similarity here. So we know that triangle 1 is similar to triangle 2, which means we know that the side lengths are, there's the P, proportional. Okay, the triangles are similar because the angles are congruent and the sides are proportional. So mathematically, if we had 3 of the 4 values, we could find the length of the shadow, right? If the sides are proportional, what might one of our proportions look like? Let's say we labeled triangle 1. What would this bottom length be? What was the bottom length of triangle 1? S. Shadow. What about this side here on the right? H. And the bottom of triangle 2? S plus D. Fantastic. And the right side? L. So a proportion here might be S over what? S plus D. And what would that equal? H over L. So that is what page 297 is asking us to do. Consider the shadow model, find similar triangles, and write how could we find the answer. So if you want to write this down as like a side note, with this given proportion or this given shadow model, we would need 3 of the 4 variables to solve for the missing one. We would need 3 of the 4 variables to solve for the missing one. And we looked at word problems like that today. However, the unit problem says, what's the length of a shadow? We want something that says S equals the length. We want it to be a function of the 3 variables that affect. We want it to be a function of H, D, and L. So right now we don't have S equals. So if we set our cross products equal to each other with what we have right now, S over S plus D equals, was it H on top? H over L. Let's say we set cross products equal to each other. We would get S times L equals H times S plus D. Now, we could, those are all variables, but we can algebraically distribute the H, rearrange, and break this apart. It's called like a literal equation where it's all variables. However, that's something that like I've done. Maybe a couple of you have seen that before. It's something you're going to focus on more in like Math 2, Math 3, and even in chemistry. You'll rework some equations to get variables by themselves. Like if you're looking at the equation for force, things like that, and you want to get variables by themselves. So page 302 says, let's look at our shadow model again. Let's reevaluate. Is there any other triangles in this problem? So the reason why, let's go back to that for a second. The reason why we ended up with 2 S's here, and we'd have to use a lot of variables or a lot of algebra to get S by itself because we had 2 S's. So what we need to do is we need to find another triangle in this model, okay, that doesn't involve S. We need to find another similar triangle that's not using S. So think to yourself here for a moment, where else could we draw in some lines to get more triangles that might be similar? Any suggestions? Austin?
From L to D.
L to D, like the top here?
Yeah.
And straight down? Okay. Okay, so what would that triangle then would have a right angle. It would have a length of D and a length of L. And it has the right angle. Does it have any other angles that are congruent? It's definitely not congruent where? Up here. Because it's a portion here. What do you think? Do you think there's any chance that this angle down here would be that top angle and then it would be flipped? Like, is there anything mathematically, like with our parallel lines and angle pairs, is there anything else we could do? So I like that triangle. It's a right triangle. I'm not seeing anything right now that I could make this angle or this angle congruent to one of the originals. Is there any other triangles we could draw in?
You could go from the top of H down to the corner of D.
Okay. Let me see here if I can get a different color. Yesterday I did not like changing. Oh, it looks like it's going to work. So top of H down to here?
Yeah.
Okay. Oh. Imagine that that's straight. So we have a right angle again. Okay, so we're looking at the height of the object. So we have H, and this length is D. So this angle down here or this angle up here, would they be congruent to either of the two in triangle 1 or triangle 2? Any thoughts here? So it's a portion of that right angle over here. So we do know that this line, the line of the object and the line of the height, those would be parallel. Let's say your yellow line here you drew, and that could be our transversal. So like this angle would be congruent to that, but that, I don't think that's going to help us because that transversal really isn't helping us with anything on triangle 2. What's another line we could draw in? Okay. Any specific spot that I should so we're going to start here at the top of H, and then you want me to go across. Do you want me to do it in any sort of fashion? Straight, so that we would create what?
90.
You want me to draw it straight over to the L to create a 90-degree angle?
Yeah.
All right. Okay. So where's the triangle that we formed? When I drew that across, I heard back here in the corner they said quadrilateral, but did we form a triangle up here? All right, so then we got a right angle. So I drew in this purple dashed line, so I created a right angle. And for those of you that are kind of multitasking right now, I need you to really focus here, okay? We have our right angle. Could this angle or this angle up here be congruent to either of the others? Nice, yeah, the top one would be congruent to this one here, and we have the right angle. So let's see what happens. Let's see now. So we have congruent angle here. We have our right angle. So we have two triangles. They are similar. They are similar by angle. Okay. What's the sides though? Uh-oh, we might be in trouble. What could we label these sides? I like it because it's not going to have an S, but do we have enough information to label any of these sides? Where would D belong? So you think D goes here? Is that the same? So D was from here to here. Would D also apply on our purple dashed line? Straight across, straight across. Yeah, because this person is 90 degrees or this object's 90 degrees. So I do agree. We can put a D here. What about, can't put anything on this diagonal because I don't have anything to compare it to. What about the side here?
L.5.
L what? L minus height. So the height of the light minus the height of the object. If I draw that in as a 90-degree angle, oh, I think we got it. We have triangle 3 with that is similar to triangle 1 and 2 by AA. The length is D and the height is L minus H. So if I now rewrite a proportion, let's see. So I have triangle 1, shadow height of the object, triangle 3, distance, L minus H. A proportion might look like this, would you agree? S over D would equal H over L minus H. And what would cross products look like?
D times H.
Good. I'm going to write this all a little bit smaller so it fits on the screen right here. So we have, now there's about 8 different ways you could write this first, this proportion. So what did I just have that you all copied? S over what? D. Okay. And now cross products would be S times L minus H. Now, if you flip the order, that's okay. So S times L minus H equals D times H. Okay, so it doesn't look like S is by itself quite yet, but an S is attached to these parentheses by multiplication. Now, if we had numbers, our first step here would be to distribute, right? But if I distribute, then I'm going to have SL and SH, so then I'm back to having S twice. Okay, so I'm not going to distribute to get S by itself, but what's the opposite of multiply? Divide. And I know this might seem a little bit crazy to some of you, but we are going to divide this whole L minus H chunk. We're going to divide it to the other side, L minus H. And so if I cancel that out, because L minus something over itself reduces to 1, I would be left with S by itself on the left side here. Shadow length is going to equal distance from light times height of object divided by length, or excuse me, not length, height of light, and this is a minus sign, minus the height of the object. There we go. We just got a function, an equation where it says S equals, and we have all the variables over here that came from similar triangles. And we knew that they were proportional, so we set up cross products. We divided the chunk over, got S all by itself. So that, ladies and gentlemen, is the solution for the length of a shadow produced by a light, a fixed light source, a lamp, right? So on Tuesday, we're going to say, okay, we're going to kind of restart. It's only going to take one day though, okay? And we're going to figure out how could we solve this for the sun. So we'll look at the sun model on Tuesday. Oh, no.